In this video, we are going to talk about graphing a quadratic function that is in vertex form, and we're going to talk about those transformations that we did in the exploration from earlier. Now, our general form of the vertex form is a times x minus h squared plus k. Remember, the squared is what makes it a quadratic, so the graph will be a parabola. And we're going to talk about what the values of a, h, and k are. So we're going to start with a, and the thing about a, it's the same value as the a from standard form. So notice in our form here, we don't have a b or a c like we did in standard form, but this value for a is the same. So if you look back to your page 4, these are what the value of a did for the standard form. Same thing's going to happen here. So if a is less than 1, the parabola is reflected. I said flipped before, now we're going to use a more mathematical. It's reflected, it opens down. Okay, so again, this a is less than 0, that means a is negative. So our examples would be like -2, or -1/3, or -2.5. Okay. If the absolute value of a is greater than 1. So ignore the sign and just look at the a value. If that's greater than 1, it's going to be a stretch. So either opening up or opening down, it's going to be skinnier. So my examples there would be like 2 or -3. And then if the absolute value of a is less than 1, it's going to be compressed. It's going to be fatter. Again, you're ignoring the sign. If you're less than 1, so like 1/2 or -1/4, those are going to be wider. Now, the value for h determines two things. The first thing is the horizontal translation. So remember, your horizontal translation means you're moving left to right. If h is positive, so if h is greater than 0, then you're going to move to the right. And if h is negative, you're going to move to the left. Now we have to be careful when we're picking that value for h, because I want you to notice x minus. See this minus? That's part of the formula. So we've got to be careful when we're determining that value for h. We're going to talk more about that when we look at our example. The other thing that it determines, it gives us the actual x-coordinate of the vertex. So it gives us the vertex, the x-coordinate, without having to do any work. Your x-coordinate is just h. That's it. And think about why that's true. If the h is determining the translation, and remember we're translating from the parent function, which has a vertex at 0, 0. Well, if I move to the right 3, my vertex has now changed to 3. All right. Value of k determines the vertical translation. And again, if k is positive, you're going to go up. And if k is negative, you're going to go down. Picking the value of k is easier because see it's plus k, so it's just whatever number's off to the side there. And then that's going to give us our y-coordinate of our vertex. And it's just going to be k. Because again, we're translating from 0, 0. All right, that's our values for a, h, and k. To summarize here, our vertex is just going to be hk. And because of that, our axis of symmetry is just going to be x equals h. Axis of symmetry is always the vertical line, so x equals, that goes through the vertex, so h. Okay, let's look at an example. It says determine the values of a, h, and k and describe their effect on the graph of the parent function f of x equals x squared. Then graph the function. So anytime we're doing our transformations using our vertex form, we are doing them based on the parent function. So with vertex at 0, 0. As I look at this one, the first thing I want to do is look for A, H, and K. Now I'm going to write right above it. A times x minus h squared plus k. That's the general form. So the A lines up with the negative. Remember, that really means -1. And then here's where we need to be careful. See how it says x minus h. So h is just 2. It's not -2, it's 2. It's always going to be the opposite. If you have x plus 2 squared, your h will be -2, because that's x minus a -2. Okay, so the subtraction is part of the formula. And then k equals 1. All right, so our transformations. The a equals -1 means you're reflected or flipped, which means that it's going to open down. The h equals 2 means that you went to the right 2. And the k equals 1 means that you moved up 1. So first I'm going to do the vertex. Ready? So normally your parent function is at 0, 0. I'm going to move to the right 2 and up 1. Or you can go straight to your key features and say my vertex is h comma k, which is now right there. Okay, now I need other points. I know it opens down, but I want to be more exact than that. So I need to find at least one other point other than my vertex. The easiest thing to do is to plug in x equals 0. So I am going to go ahead and over here I'm going to find my y-intercept. And it's going to take me a little bit of work. So I'm going to do g of 0 is -0 minus 2 squared plus 1. Which is -0 minus 2 is -2. Remember, you're going to square first. -2 squared is 4. Bring down the negative, bring down the 1. And I get -3. So this is the point where x is 0, y is -3. That's the only point I need to find, because I'm going to use symmetry for the rest of it. So I'm going to go back to my graph, and I'm going to plot the point 0, -3. So to the left and right 0, and down 1, 2, 3. So my y-intercept is right there. My axis of symmetry is x equals 2, which I've drawn in red. And the reason I did that is because now I can use my symmetry to get the other point. So see right there? It's 2 to the left of that line. I'm going to go 2 to the right of that line. And that'll give me that point. And that's enough to draw in my graph. And then finishing up my key features. So I have my vertex, I have my axis of symmetry. It looks like my zeros are nice and pretty. So it looks like my zeros are 1, 0, right there. And 3, 0, right there. We'll talk about how to find those more precisely later when we talk about solving. But for now, we're just going by the sketch. Again, my y-intercept, we already found to be 0, -3. And what key feature am I missing? Domain and range. So my domain, remember your domain is your set of x values, and your domain for parabolas without context will be all real numbers. And then my range, this one opens down. So that means my vertex is a max. So my y value is 1. So all my y values are less than or equal to 1. Because my parabola opens down, my vertex is a max. So my range is y is less than or equal to 1. And that is it.